This is lesson 8, and we're talking about representing proportional relationships with equations. As soon as we say equations, immediately you need to think of y equals k over x. Whoa, what am I saying? Y equals k times x. And we can find k by doing k equals y over x. Okay, so if we can substitute in here, these are equations because they've got an equal sign and variables. All right, so we need to remember that proportional relationships have a constant ratio or unit rate, and that constant ratio or unit rate can also be called the constant of proportionality, which we did yesterday. So first example, your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating that there is a half gallon left in the tank, in the gas tank. So that's pretty important. There's a half gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the gas station, to the next gas station. So the chart that she recorded, when she got 8 gallons of gas, they were able to drive 224 miles. When she got 10 gallons of gas, they were able to drive 280 miles. And when she got 4 gallons of gas, they were able to drive 112 miles. So the first thing, A, says find the constant of proportionality and explain what it represents in this situation. So we've got an extra column on our table here. And so to find the constant of proportionality, we remember that k is equal to y divided by x. So which one's the y and which one's the x? Well, we need to know which one's the independent variable, and independent is the x, and which one's the dependent variable. So we need to know, does the number of gallons depend on the miles driven, or does the miles driven depend on how much gas you have? Well, how many miles they can drive depends on how much gas they can have. So miles driven is the y, and gallons is the x. And that makes sense because we normally talk about, when we talk about gas consumption of a car, and we're going to buy a car and we want to know how much gas mileage it gets, we say, how many miles per gallon does it get? And in this situation, x is gallons. So we're going to take 224 and divide it by 8. And when we do that, we get 28 miles per gallon. And if we do 280 divided by 10, we also get 28 miles per gallon. And if we take 112 divided by 4, that's also 28 miles per gallon. So the constant of proportionality in this situation is 28 miles per gallon. So the car travels 28 miles, I'm going to say goes 28 miles on 1 gallon of gas. All right, whoops, I'm sorry, I cut that off there. The car goes 28 miles on 1 gallon of gas. All right, so then the next thing, B, but it states write equations that will relate the miles driven to the number of gallons of gas. Well, we already know, because up here we know that y is miles and x is gallons. So we can say y is equal to k times x. Well, in that situation, we were saying whatever dependent variable you have, if you take 28 times the independent variable x, you'll be able to get the dependent variable, which is miles driven. Now, instead of using y and x, you may want to say, and we've done this a lot when we've done algebraic equations already, is instead of calling it y, we might want to call it m for miles driven and g for gallons. Well, in that situation then, we'd say miles driven, which is just like the y, is equal to 28 times the, not times the x, times the g. Okay, then C says, knowing that there is a ½ gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Okay, so there's a ½ gallon left in the gas tank when the light comes on. Will she make it to the nearest gas station? All right, so we remember the nearest gas station, if we look back up here in the original problem, is 26 miles away. So if there's a ½ gallon, well, here's our gallons here. We know if there's 1 gallon, how many miles can they go? 28 miles. So if you cut that gallon in half and cut 28 in half, that means it can go 14 miles. So if it can go 14 miles on a ½ gallon, then the answer would be no. They definitely can't go 26 if a ½ gallon will only get them 14 miles. So we say no, because she gets 28 miles per 1 gallon, or to 1 gallon. So she can only go 14 miles, half of that, on half the amount of gas, which would be a ½ gallon. All right, so then D says, using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. Okay, so now she's got 18 gallons of gas, and we're going to use this equation up here. Miles equals 28 times G. And G, in this case, is going to be 18. So we're going to substitute in 18 for G. And that'll be 28 times 18 will equal the number of miles. And 28 times 18 is going to be 504 miles. All right, then in D, using the equation found in part B again. So we're going to be using the equation M equals 28G. Determine how many gallons of gas would be needed to travel 750 miles. So this time we're going to go 750 miles. And so we're going to now substitute 750 in for M. So that's going to be 750 equals 28 times G. Well, that's a one-step equation, which we've done a lot of those already. So to get G alone, that means we're going to have to divide both sides by 28. And when I do that, 28 divided by 28 is 1, and 1 times G is G. And 750 divided by 28, where am I at here? My calculator. Okay, 750 times divided by 28 is 26.8. So 26.8 gallons of gas would be needed to go 750 miles. All right, so now let's look at our next example. And our next example is about Andrea's portraits. And for Andrea's portraits, read the problem there. So it says, Andrea is a street artist in New Orleans. She draws caricatures, cartoon-like portraits of tourists. People have their portrait drawn and then come back later to pick it up from her. The graph below shows the relationship between the number of portraits she draws and the amount of time in hours needed to draw the portraits. So here's the graph over here. And so the number of portraits she draws, that is the N. And the N is on which axis? Yep, that's the y-axis. And remember, y is the independent variable. So let's just write this down. The more we do it, the more we'll remember it. Okay, then this axis here is the time spent drawing, and that's T there. So that's the x-axis, which is the, oh crap. Oh, I'm sorry. It's late. Okay, so the dependent variable is y, depends on x, which is the independent variable. All right, so again, the more you would think, oh, Mrs. Stevens, you've done it a lot. You're 50-something years old, but it's because my gray matter is getting old. Okay, so anyway, we've got t is the independent variable and n is the dependent variable. And if we look at the graph, we can look at some coordinates that actually fall on the line. And let's see, one of them that's pretty, I guess, pretty obvious. If we go for 4 hours, he can draw 6 pictures. If he goes for 6 hours, he can draw 9 pictures. In this graph, I think well, no, it doesn't, but it's hard to see unless you actually have a straight edge or you've got actually the grids in there. If he goes 2 hours, he can draw 3 pictures. And if he goes, ooh, okay, well, that's enough there. Okay, so it says write several ordered pairs from the graph and explain what each coordinate pair means in the context of the graph. So let's start with 2, 3. So 2, 3, because remember this is the x-axis, and so the independent variable always goes first, and the dependent variable goes second. So in this case, x-axis, y-axis, or we're going to say t and put that over the x, and we're going to put n over the y, just so we can keep track of that. Okay, so you got 2 to 3, or 2 for every 3. And for 4 hours, you can draw 6. And for 6 hours, you can draw 9. And so what this means is that in 4 hours, or I'm sorry, here in 2 hours, remember that's t, the time, she can draw 3 pictures. Okay, so in this one, in 4 hours, she can draw 6 pictures, and the ditto marks just mean same thing as above. And so 6, 9 means that in 6 hours, she can draw 9 pictures. Now, what's the unit rate? Well, remember the unit rate is how many pictures she could draw in 1 hour, because we're doing pictures per hour. Pictures are, yeah, the number of pictures she can draw per hour. Because if it's pictures over hours, then that's going to be y over x, which is the dependent variable over the independent variable. So in this case, the unit rate, well, if we, or the constant of proportionality, we would be 3 over 2, or that could be 6 over 4, or that could be 9 over 6, and every one of those, if we divide 3 by 2, we get 1.5. 6 divided by 4, we get 1 2/4, which is 1.5. 6 divided by 9, we get 1 3/6. So every one of those is 1.5. Now, it's 1.5 if I divide by 2 here and divide by 2 here. 3 divided by 2 is 1.5. 2 divided by 2 is over 1. So she can draw 1.5 pictures in 1 hour. Okay, so then in B, I think I just solved that actually. It says write several equations that will relate the number of portraits drawn to the time spent drawing them.